Okay, just a quick review of reference angles before we get into the next section. Just so you remember, if my angle falls in the first quadrant, this is theta, then theta is going to equal its reference angle. Okay? If it falls in the second quadrant, and this is my theta here, so I put the reference angle in blue, then my reference angle falls right there. Okay? And turns out to be my reference angle is going to equal 180 minus my original angle. Okay? If it falls in the fourth quadrant here, okay, and this is my theta, then its reference angle again is made with the x-axis, okay, and in this case is going to equal theta minus 180, or pi, you know, if you're dealing with radians. And lastly, if the angle falls in the fourth quadrant here, all the way around, then my reference angle is made here, and my reference angle is going to equal 360 minus my original angle. Okay? And we need to use those here. Okay? So, which we kind of discovered in a previous chapter. Evaluate the 6 trig functions for theta equals 5 pi over 4. And so what we need to do is I'm going to draw in 5 pi over 4, which puts me right here in the third quadrant. Okay, this is 5 pi over 4. Hopefully you've had some work with reference angles. So here my reference angle is pi over 4. Now, in the past we've used our reference triangle, or our unit circle, but you don't even have to do that based on what we talked about before. The unit circle's radius is 1, but any triangle that you make that has a point on this terminal side of the angle will be similar to that triangle. Here's the point, is that we've been calling this radius 1, but really what you could do if you wanted to, if you're a little more comfortable with this, is call the radius square root of 2, and that makes, of a 45, 45, 90 triangle, the sides just 1 and 1. Again, since we're in the negative directions here, you might want to label them as negative. Once you do that, it's easy to find out what the evaluate sine of 5 pi over 4, cosine of 5 pi over 4, because all we have to do is refer to its reference triangle, which is this one right here. Now that we've drawn its reference triangle based on its reference angle, we just consider this our reference angle and say, okay, sine of 5 pi over 4 will actually equal negative 1 over the square root of 2, which we should know at this point rationalizes the square root of 2 over 2. Cosine of 5 pi over 4 is going to also equal negative square root of 2 over 2. Tangent of 5 pi over 4 is going to equal negative 1 over negative 1, which is positive 1. Okay, opposite over adjacent. Okay, then we go through the reciprocals. Now, you could go through and do this, you know, a number of ways, but let's just look here. Cosecant, we know from the last section, is hypotenuse over opposite, so we get negative square root of 2. Secant of 5 pi over 4 is also negative square root of 2. Cotangent, which is the reciprocal of tangent, and can be confirmed a number of ways here, will equal 1. So that's how we use reference angles to help us evaluate these trig functions. You're not limited to just the unit circle.